Hello everyone, welcome to the electrical circuit simulation series. In this session, we'll study OPAMP as an inverting amplifier, the use of OPAMP as an inverting amplifier. So this is the required circuit of the OPAMP and the other components. So let us see the components. The first component is the OPAMP itself. So we connect OPAMP in this way. So this is the input. Input is connected to the inverting end through a 100 ohms resistor. Then of course we have this resistor as the input, we name it as R1. Then we have the feedback resistor which is connected between the inverting and the output, so we call it as RF, so it is 200 ohms. Then we connect the ground to complete the circuit, and then we have the voltmeter to measure the output voltage. So let us see the calculation part. So this is the input VIN, we denote it by VIN. Then we have R1 as the input resistor, RF as the feedback resistor, and V0 as the output. So given these things, given these parameters, the output V0 is calculated as VIN minus of VIN into RF upon R1. So this is the formula we get. Okay, when we do the analysis, we get this V0 equal to minus VIN upon RF upon R1. So this minus because we will get, this is actually an inverting amplifier. The reason it is inverting amplifier because the output is always out of phase with the input. So whatever input we are giving, output is always out of phase. So therefore we get this negative sign. So RF in our case is 200 ohms and R1 is 100 ohms. So we put in the values and we get this as V0 equal to minus 2 times VIN. So whatever input we give, it is doubled with a negative sign. This is what we get. Okay. So as you can see, if the input is 0 volt, the output is minus 4.028. So it is doubled and with a negative sign. So this is how we see the working. Now let us go for the simulation part. So now we are in the SimulIDE. Let us select the components. So we start with the power supply. So this is the voltage source, we take this voltage source. Then we take the resistors. So first this is the input resistor, and then we need a feedback resistor. So this is the feedback, we connect it here. Okay. Then we need OPAMP. So here we have the OPAMP. This is the OPAMP, we connect it here. Then we need two more components. One is the ground and the voltmeter. So here we have the ground, I give it here, and then the voltmeter. So this is the voltmeter. Now let us connect the components. Now before connecting the component, actually the inverting end is down and the non-inverting is up. So I'll just flip this. Okay. So I'll just right click and flip vertical. So now I have this negative, the inverting end at the upper side. We can even connect that way, but this is more visual. So this is the connection we do. So the input is connected to the inverting end. Then here we have the output. I connect this output here. So then this is the feedback, and we connect the inverting non-inverting end with the ground. So this is the connection. Now then this is 100 ohms by default, so we need to change this to 200 ohms. So we can put any value as required. So the gain is actually controlled by this. So this is 200 ohms. So in the formula we saw that it is RF upon R1. So this RF upon R1 is the gain. So gain is 200 divided by 400 is, that is 2 is the gain. Okay. Then we connect this to the ground. This is connected. Okay. Now before turning on the power, we must check this actually. So if we go in the properties, this setting must be done. If this setting is not done, we won't get the proper output. So we just see the supply. And in the supply we see this V plus is 5 volt and V minus is 0 volt. So we won't get any output. So we need to set this. And one more thing is that it will saturate on 5 volt. So we put this, we make this voltage as 10 volt and this as minus 10. Okay, so we need to put the minus sign and then 10 volt. So this setting must be done, otherwise we won't get the proper output. Okay, now let us turn on the power supply. Okay, now this is input is 0. Now let us make it as 1 volt. So we will make it at 1 volt. Okay, so with 1 volt, 1.0, so we are getting 2. Okay, so with 1 volt, input is 1, output is minus 2 around. Then let us make it as 2. So with let us take 2.5. With 2.5, the output is minus 4.985. This is almost equal to 5 minus 5 volt. Then if we make it this particular as 5 volt, we get it as -9. It is almost equal to -10 volt. Okay, so why did we make this setting? If we, let us check by one more time this particular settings which we did in this properties. This is 10 and -10. So if we don't make this setting, the output won't go beyond 5 volt, and this setting -10, it is done so that we also get the negative values. Okay, so this is the we only need to set this thing. So that's all for this session. Thanks for watching.